Okay, we're back, and we are on the back of the notes here. So now the third part of these notes, finding the nth term of a geometric sequence. So here's the formula. A sub n equals a sub 1 times r raised to the n minus 1 power. A sub 1 is the first term. R is the ratio, the common ratio. N is the number of terms. It's the number of numbers. So to find the nth term, we're going to take the first, we're going to multiply it by the ratio raised to the n minus 1. So this is an exponent, n minus 1. So let's do an example, number 4. A sub 1 is equal to 5, r is equal to 3. What is a sub 12? Well, so a sub n, that's going to be a sub 12, equals, let's set this up, a sub 1 is the first term, which in this case is 5, times the ratio, which is 3, raised to the n minus 1. Now we have 12 terms, so I'm going to subtract 1. So what this gives us is 5 times 3 to the 11th. In geometric sequences, your numbers will get very big very fast. So 5 times 3 raised to the 11th, 885,735. So a sub 12 equals 885,735. All right, that's pretty big. But again, think about what you're doing. You're multiplying by 3 every time. 5 times 3 times 3 times 3, 11 times. Okay, let's do number 5, same thing. A sub 9 equals the first term, 640, times the ratio raised to the n minus 1. That would be 9 minus 1. So this is 640 times 1/2 to the 8th power. 1/2 raised to the 8th is going to be a fraction. That would be 1 over 256. So 640 times 1 over 256. Okay, if I take the, just to show you, 1/8 raised to the 8th power, okay, gives me a scientific notation. Oh, it's not going to give it to me. All right, so I have to do, oh, it should be 1/2, excuse me. 1/2 raised to the 8th power. Sorry about that. Math, enter, enter. There's 1 over 256. Okay, so I'm going to multiply that by 640, and we get 2.5. So the 9th term here is 2.5. And because this was a fraction less than 1, that means we're going down. It's like you're dividing by 2 every time. So divide by 2 until you get to the 9th term. Now in number 6, fill in the blanks for the geometric sequence. So we're going to multiply by something to get the next blank, and then multiply again to get the blank, and then multiply to get 54. So can we figure out what that ratio is, what that number is that we keep multiplying by? You could start it by thinking of it as x times x times x, and then times x to get 54. So starting with 2, we multiply by x to the third. X times x times x equals 54. Divide by 2, we get x to the third equals 27. Take the cube root of both sides. To solve that, we get x is 3. That would be your ratio. So we're going to multiply by 3. 2 times 3 is 6, times 3 is 18, times 3 is 54, times 3 is 162. Okay, and that is your answer to that. Okay, so, again, the understanding of a geometric sequence is that you are multiplying every time to get the next term. You multiply by the same thing. So what happens if we want to find the sum? If we have a geometric series, if we want to add up the terms in a geometric series, the formula is S sub n equals a sub 1, the first term, times 1 minus r to the nth power, all divided by 1 minus r. So you've got the first term, you need the ratio, which is r. You also need the number of numbers that you're doing. So number 8, find the sum of the geometric sequence, 2, 4, 8, 16, all the way up to 512. Well, you can look at this and you can see you're multiplying by 2 every time. Now we have a gap here between 16 and 512. I need to know which term this is. So one way to get it, I can just keep counting. So 16, 32, 64, 128, keep doubling it, 256, and finally I get to 512. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 terms here. So I'm going to find S sub 9, the sum of the first 9 terms, equals A sub 1, the first term is 2. That's how we started. Times parentheses 1 minus r to the nth power. Well, r equals 2. We're doubling it every time to get the next number. So it would be 2 to the nth. N is 9. We're trying to find the sum of the 9 terms. Minus 2 to the 9th. All over 1 minus r, which is 2. Now what happens here is you get 2 times 1 minus 512. That's 2 to the 9th over negative 1. And that's 2 times negative 511 over negative 1. And what we end up getting here is 1022. That would be the sum of all those numbers. Now in this case, it's not a lot of numbers. You could just have added these up individually and gotten to the same place. But the formula might take you a little bit shorter. So let's take number 9. Find the sum again of each described geometric series. First term is 16. The ratio is 1/2. And we're going to find the sum of the first 7 numbers. So we're going to say S sub 7 equals A sub 1 times 1 minus r. Okay, the ratio is 1/2 raised to the nth power. That's 1/2 to the 7th, all over 1 minus r, which is 1/2. Okay, we're going to simplify this here. This will be 16 times 1 minus, this will be 1 over 128, all over 1 minus 1/2 is 1/2. Now, just to save a little bit of time here, what's going to happen is I can combine the fractions and then multiply by 16. And what I get out of that is, let's see, it'll be 16 times 127 over 128, all over 1/2. Gotta know I'm kind of writing small here. And this will be, that will reduce to 8. So it's 127 over 8 times, I'm going to change multiplication or division to multiplication, so I'm going to flip the bottom fraction times 2 over 1, and what we get is 127 over 4, or 31.75. Now I know that was kind of messy what I just did here. You can use the calculator. If I type the numerator, which is 16 parentheses 1 minus, I'm going to do 1/2 to the 7th. Alright, that gives me a decimal, and then I'm dividing by 1/2. There's 31.75. Okay? If you use the calculator, be very careful how you type. I would do the numerator, get a number, and then divide it by the denominator. Part B, A sub 1 is 4. R is 3, that's the ratio. We want the sum of the first 8 numbers. So it's A sub 1 times 1 minus the ratio raised to the 8th power, 1 minus 3 to the 8th, all over 1 minus r, which again was 3. Okay, so you're going to have 4. 1 minus 3 to the 8th is going to give you negative 6,560. And then 1 minus 3, we're going to divide by negative 2. So we'll work that out, and what we get is 13,000. I'll write it down here. 13,120. That would be the sum. Okay, again, you could think of it, if the ratio is 3, it would be 4. 4 times 3 is 12. 12 times 3 is 36. Times 3 is 108, so on and so on. And you can add all those up, okay, the first 8 terms. Part C. All right, so this is a summation notation. Now the first number to plug in is a 5. And I'm going to plug it into this whole function right here. So it'll be 1/2 times 3 raised to the 2 times 5 minus 9. That's the first term. Plus. Next digit I'm going to plug in is a 6. 1/2 times 3, 2 times 6 minus 9. Plus 1/2 times 3, 2 times 7 minus 9. This is all an exponent. The 2n minus 9 is all an exponent. Now let's see, I plugged in 5, 6, 7. I have one more number. I'm going to go to 8, plug it in, and then stop. So plus 1/2 times 3, 2 times 8 minus 9. Okay, now there's a lot of simplifying here. In the first exponent, this will be 10 minus 9, which is 1. So we have 1/2 times 3 to the first. And then the second term, 2 times 6 is 12, minus 9 is 3. 1/2 times 3 to the third. 1/2 times 3 to the 14, minus 9 is 5. And then plus 1/2 times 3 to the 7th. When you work this out, and you can check my arithmetic, you'll get 1,230. So that would be the sum of those terms. You got to start with 5 to plug in for n, and then 6, and then 7, and then 8. You have to copy all the other stuff there. All right, one more thing that we'll discuss, and that is an infinite series, and finding the sum of an infinite series. So it's S infinity. Sum of an infinite series is a sub 1 over 1 minus r. Now you might be asking, how is it possible that if you're adding an infinite number of numbers, that you're actually going to come up with one value for that? Well, let's look at an example. Number 10. What's the sum of the infinite series? 9 minus 6 plus 4 minus 8/3 plus ... First thing we need to know is what's the ratio? What is the common ratio? We're definitely not adding the same thing or subtracting the same thing. What we're doing is we're multiplying. To find it, I'll take the first 2 terms. I take the second term divided by the one in front of it. And I can reduce that. That's going to be negative 2 over 3. That is my common ratio. So what we're doing is we are multiplying by negative 2/3 every time to get the next number. So what happens though, notice that your numbers are decreasing and they will continue to get closer and closer to 0. You notice that it's positive, negative, but each time your values are getting closer to 0. If you were to continue, eventually it would be so small that it wouldn't really affect the value. And so it would actually add up to one number. It would be approaching one value. So S sub infinity, here's the formula, equals a sub 1, which is 9, divided by 1 minus the ratio. The ratio is negative 2 over 3. I'm going to simplify that. That's 9 over. Minus a minus is plus, so that's 1 plus 2/3. Now if I add that, that would give me 5 over 3. So I have 9 divided by the fraction 5/3. So I keep the top number. I'm going to change this to multiplication, and I'm going to multiply by the reciprocal, which is 3 over 5. I flip the fraction, and what we get is 27 over 5, or 5.4 as an answer. So that is actually the sum of an infinite series. So even though you'd be adding an infinite number of numbers, you actually get a finite value for the answer. All right, that may be a little confusing, but try a few more problems and I think you'll understand it. That is the end of the notes.